All right, so we're going to start with two parallel lines. I can give you the equations of those parallel lines. This line is y equals 1x, 1, 2, 3, 4, 5, 6, 7, plus 7. And this line is y equals 1x, 1, 2, 3, 4, 5, 6, minus 6. How do I know they're parallel?
They have the same slope.
Same slope. Beautiful. So if I try to find the point of intersection between those two purple lines, what's going to happen? There will be none. No solution. We'll get an error. We'll get negative 2 equals 7. We'll get 10 equals negative 4. It won't work. The question today is, how far apart are those parallel lines? So imagine you've got two train tracks. And by the way, hopefully you realize that train tracks have to stay parallel, otherwise you get a mess on your hands. I would like to know the distance between those parallel lines. And based on what we did yesterday, how do you think we're going to measure that distance? So I could just take a vertical distance, right? If I understand what you're saying correctly, you're saying I could just do this. Okay. Well, we need some consistency, right? Because if I build train tracks in Illinois, the train tracks in Pennsylvania have to be the same distance apart. So how do I explain that distance to somebody in Pennsylvania? Because in Pennsylvania, couldn't they do this? That's going to be a big problem. If the train tracks all of a sudden get smaller or wider when you cross into Pennsylvania, you're going to have a lot of train wrecks on your hands. So we need some consistency. Hans, what do you got?
The y coordinate, so y2 plus, or no, minus y1.
That's that vertical line that I just drew. Okay. There is a distance between these two parallel lines that stays consistent regardless of where I'm... Charlie?
You can find like the slope between two specific parts
Okay.
and like just say the slope.
And how can I use that to get a distance?
Well, you could say, like if the slope was like 1. then
It is 1.
Oh, wait, are you saying it is 1 or?
The slope of those lines are 1, yeah.
Oh, okay, so you could say, the slope is 1, and so do that however many times.
Okay, so what does that phone call look like when you're calling your friend Bill in Pennsylvania in the train yard?
Hey, Bill from Pennsylvania.
Which is funny because that's what he goes by.
Yeah. Your train tracks, so they're the perfect distance away. You got to give them a slope of 1, and do that slope of 1 5 times. No problem, Bill from Pennsylvania. All right, see ya.
Thanks, Charlie from Illinois. You understand the problem that we're facing here? Daniel?
Like find a point on the line.
And then what?
And then use it, like put it in the punch scope one.
Okay, so again, how does that sound on the phone with Bill from Pennsylvania? So I know, I've come up with a way to measure the distance between my train tracks and here in Illinois. Now I have to call Bill in Pennsylvania and say, Bill, here's what I'm doing to measure my train tracks. Are your train tracks the same distance?
Find the distance between the two y-intercepts.
Okay, so what does a y-intercept look like in a train yard?
Once you find the distance, you don't need y-intercepts.
Well, that's how to win $1 million. First, get $1 million. Then you've won $1 million. So it doesn't matter how you got it because you already got $1 million. That's how you win $1 million. You're cheating. Yes, sir?
So you find like the midpoint between the two parallel lines, and then you...
Okay, wait, hold on. let me interrupt you for a second. Let's think about what you just said. Find the midpoint between the two parallel lines. How long's a line?
Infinite.
Infinite. Where's the midpoint?
Oh, wait, anyway.
How can I measure the distance between those parallel lines that gives me a consistency that's universal?
Say question.
When, who was on fire the other day? Charlie, when you were on fire, how did you run to the river?
Straight down.
Do you think that was a universal approach that most, who else was on fire? Grace? And is that it, just the two of you? Yeah. Do you think that would be a universal approach that everyone on fire would follow? Or, let me rephrase the question, because who knows what you're gonna do when you're on fire.
Yeah.
Do you think that's a universal approach that everyone should follow
Yes.
when they're on fire near a river?
Yes.
Grace, do you agree? Good. So we need a universal approach to finding the distance between these parallel lines that makes sense for Bill in Pennsylvania, Charlie in Illinois, and anybody else that's doing train tracks. Or building roads, or, what do you got?
Do a perpendicular line.
So if I take a perpendicular line here, I think Charlie just had an epiphany.
I got it. I
Okay?
understand.
There's a perpendicular. Is that going to be universally true? If I take that perpendicular down here, will those two distances be the same? Yes. Hey, Bill,
Oh, yeah, what's up, Charlie?
look, I'm measuring the distance between my train tracks. I got to set up a perpendicular. I got a distance of about blah, blah, blah feet. How's yours?
Oh, cool, let me check. Oh, yeah, mine's blah, blah feet too.
Excellent. Thanks, Bill.
No problem,
Have a good day, man.
Yeah, you
Say
too.
hi to Sue, your wife.
Oh, yeah, you too.
Okay, bye.
Bye. You too.
So I married to Sue also? Is that what we got out of that discussion? All right.
They're no, it's an odd family, you know?
All right. So what we've done is we've established the groundwork for what we need to do. If I want to know the distance between those parallel lines / train tracks, I want to measure that distance along a perpendicular because that will give us a universal distance. We'll call it D. Now the question is, how? Yeah,
Find the slope of the perpendicular line.
we can do that. What would the slope of this blue line be, Daniel?
1.
Oh, -1.
-1. Opposite reciprocal, the flopposite would be -1. And we'll do another example where the slope isn't something as nice as 1. All right, so then what? How does that help me?
It helps because now you just gotta find the 2 points of where it intersects with the 2 parallel lines.
How?
What?
How? I don't know where those 2 points are.
Find
How?
by looking at the parallel.
Bill?
Oh, hey, what's up, Stanley? Charlie?
Stanley Charlie?
Sorry about that, Bill.
I got divorced and hyphenated my name now. Stanley Charlie.
Okay.
Yeah, so I'm measuring the distance here, and I'm not sure what point to use on one of those rails. Any ideas?
It's a real goof. Any ideas?
Yeah.
Well,
I'm in quite the pickle, as they say.
oh, sure thing.
Uh-huh.
Well, since they're parallel lines, aren't they gonna be an equal distance across anywhere?
I hope so. They better be, or we're gonna have a lot of train wrecks on our hands.
Oh, that'd be a real problem.
Uh-huh.
So what's the question?
I'm on the clock here, Bill.
I'm sorry. What seems to be the problem?
Bill, I'm getting a stink eye from my supervisor. Can we speed things up here? I don't know what points to measure that distance from. Any
Oh.
ideas?
Well, I would say where it intersects to make a 90-degree angle.
Oh, all right, thanks, Bill.
No problem,
All right,
Charlie.
love to the kids.
Oh yeah, you say hi to.
Oh, how funny, my kids are named Ta and Ta. Thank you, Bill, bye. All right, where's that point? Where are those points? Anywhere and everywhere is a little broad, we might want to narrow that down. So this is what's going to freak many of you out. There are an infinite number of ways to solve this problem. Yeah. In the problems we looked at on the homework yesterday, there was only one way to do it, and we all solved them the same way, assuming we solved them correctly. This problem has an infinite number of solutions. If you go back to the train track, think about it, I can go to any point on that train track, stop, and measure that perpendicular across the train track. The same is true here. So, we're going to start by picking one of these lines. Hey, Bill.
Oh, yeah, Charlie. Let's
Yeah, which line should I use? I'm thinking 1x plus 7 or 1x minus 6. You got a preference on that?
I would prefer 1x plus 7 because 7 is my lucky number and it's a positive number.
All right, thanks, Bill. Hey, how's the dog, by the way? Get him back from the vet yet?
Oh, yeah, he's back. He tore his Achilles, though.
Oh. You know what they usually do with dogs that tear their Achilles?
Put him down.
Yeah, all right.
Yeah.
Gotta go, Bill. Bye. Bill.
Oh, hey. Oh,
I'm sorry, I'm racking up quite the phone bill here.
Yeah, I know.
Phone bill, get it?
That's a good one, Charlie. Man.
Hey, Bill, can you tell me a point on that line that you suggested with your lucky number?
Oh.
I just need one.
We're gonna go with 0.6.
0.6. Bill, there's a bunch of noise in the background. I'm gonna have to hang up now. I'm breaking up.
Oh, okay, have a nice day.
Okay, bye. All right, we're gonna have to get done, get seated. Let's go. Let's finish this up before the bell rings. I know we have a minute, but otherwise you're gonna be dead in the water if you can't get this done. Okay, so Molly, back to you. Give me a point on that line. Beautiful. Okay. 0.7 is one of how many how many points on that line, Molly? Infinite. Do you have to use 0.7? No, but it's a good number. I could use 1/8. I could use 10/17. I could, don't start packing up. Give me 2 seconds. You could use an infinite number of points on that line. Then, if I do this, and get rid of all this stuff, knowing where this point is, can you solve the distance? Yeah, so here's a couple hints for tonight. Number one, you have to pick a point on the line, stop. And number two, after you pick that point, cross that line out because you're never going to use it again. All right? Get out of here, go on. Mind me tomorrow, I'll tell you a funny story about a lockdown drill. Which seems kind of contradictory, but you'll have to trust me.
That's good.